Everyone, this is from Group 3. This is our group member Amira, Nurin, June, Jasmina, Shamim, Ashley, and Amanda. Today, we are here to talk about the homeostasis. Oh, no, sorry. It's homeostasis. Oh, okay. Homeostasis actually means the process of physical and chemical condition in internal environment of our body maintained within tolerable range even when the external environment condition is altered. Homeostasis actually involves two types of mechanisms, which are positive feedback mechanism and negative feedback mechanism. Today, our group are just going to cover about the negative feedback mechanism. One of them are thermoregulation. Have you ever wondered how our bodies react when the temperatures go too up or down? Before we discuss about that, we have to know the types of animals, which are endotherms, involve mammals and birds, and ectotherms, which are reptile, fish, and amphibians. Before we discuss about thermoregulation again, we have to know how the heat transfer, which are conduction, which transfer through the metals, convections, which transfer through air and water, and radiation through the infrared.
First, we are going to talk about thermoregulation in reptiles. Reptiles are ectothermic animals, which means that they can't generate their own metabolic heat. Hence, they rely on environmental heat to maintain their body temperature. A reptile has a normal body range of 24 degrees Celsius to 35 degrees Celsius. Reptiles are also thermophilic, which means that they require high temperature for physiological functions. Since reptiles cannot generate their own metabolic heat, they would have to require on behavioral traits to regulate the temperature. For example, reptiles will move to different areas to cool down or heat up. If it feels too hot in the sun, a reptile will find shade or even go into the water to cool down. There are two ways that reptiles can conduct heat. The first one is through radiation. For example, a reptile will sunbathe by sitting on a rock when its body temperature is too low in order to radiate heat from the sun. In addition, a reptile can conduct heat from the rock which is hot from being in the sun. On the other hand, in order to cool down, a reptile can undergo evaporation. A reptile's nasal cavity contains fluids, and when its body temperature is too hot, these fluids evaporate, releasing heat from the reptile's body. The next way the reptile can cool down is through convection. A reptile undergoes convection by movement of air or breeze on its tail. Different reptiles will depend on different behavioral traits to keep their body temperature constant. For example, when it is too hot, a crocodile will jaw its jaw agape in order to cool down. The next example is that frilled dragons and coiled lizards will run on their hind legs when it is too hot, generating an artificial breeze to cool themselves down.
Next, we'll talk about thermoregulation in avians. Avians can maintain a high and constant body temperature, or homeotherm. When the environmental temperature decreases, the bird raises its metabolic rate to prevent its internal body temperature from falling. On the other hand, when environmental temperature increases, the bird mobilizes water to release heat by evaporative cooling.
I have one interesting fact here for you. Birds do not have sweat glands, so they actually pant to release heat. Birds pant by vibrating their gullet or throat muscle. This action causes air to be pumped back and forth in their respiratory system, which results in evaporative cooling. Birds also have unfeathered legs to encourage heat loss. Avians also carry out thermoregulation in their behavioral traits. For example, they stand on one leg and tuck the other under their breast feathers. Additionally, they carry out urohydrosis, which is essentially urinating on their own legs to help themselves cool down. Urohydrosis has another benefit in addition to thermoregulation. This is because a bird's urine contains acid which can kill bacteria. For behavioral traits to maintain heat, on the other hand, birds sit down and cover both legs in their feathers. They also tuck their beaks under their wings and fluff up their feathers. Fluffing their feathers traps air, which adds another layer of insulation.
For metabolic reaction, avians carry out countercurrent heat exchange. Countercurrent heat exchange happens when warm blood or arterial blood from the avian's body cord travels down the leg. This arterial blood passes heat to cold blood, also known as venous blood, coming from the foot. Hence, arterial blood is now cooler and will lose less heat to the environment as it travels through the foot. Avians can also experience heat stress. Their cells will produce heat shock protein to prevent cells from dying due to overheating.
See animals sunbathings like us. Ever wonder why they do that? Actually, this is how they regulate their body through behavioral thermoregulation. The first example is basking. The principle is to transfer solar radiation into heat and passively warm up the body. Secondly, is a ball-like posture. It is to reduce the surface to volume ratio to minimize the contact surface with air, thus reduce the area of heat dissipation. And next is a nest building. It is strongly associated to parental care by providing shelter with insulation capacities to protect future offspring. The last one is huddling. This strategy consists in the aggregation of numerous individuals to limit energy dissipation, thus decrease the energetic needs for body heat production. The next part is hypothermia avoidance in mammals. The firstly is panting. It is to dissipate huge amount of body heat induced by water loss. It can be observed in mammals such as dogs and sheep. The next one is habitat selection. Most mammals avoid the heat of their environment by retreating in shaded, cooler place.
I'm also going to talk about involuntary action or non-shivering thermogenesis in mammals. In high temperature condition, the thermoreceptors in the skin will detect the abnormal temperature and send an impulse to the hypothalamus, also known as the hot center. The hot center then stimulates the sweat glands to produce more sweat. Erector pili muscles relax and the mammal's hair flattens, so most of the sweat produced can evaporate. Hence, heat is lost through evaporation. At the same time, the erector pili muscles relax, causing hair to flatten so that most of the heat can evaporate. At the same time, vasodilation occurs. Vasodilation occurs when the blood capillaries expand and move closer to the skin to release heat through convection. The body temperature of the mammal is then maintained at a normal range. When under low temperature conditions, on the other hand, mammals carry out the inverse of involuntary action. At low environmental temperatures, vasoconstriction occurs. This diverts blood capillaries from the skin surface to help prevent heat loss by radiation and convection. At the same time, the erector pili muscles contract and causes the pileo reaction to occur, trapping a stationary layer of air to serve as an insulation layer. When we are cold, we also shiver, which is the rapid contraction and relaxation of skeletal muscles which produces heat. The thyroid gland will also release thyroxine, which increases metabolic rates.
Do you ever wonder why our body temperature increase in sudden during fever? Or wonder about why you're shivering and your skin still feels so cold to be touched? Actually, is a disease condition also named as pyrexia. It is a condition where your normal body temperature set point is altered, of course, to the higher temperature. That's why you feel hot during fever. Condition, bacteria which invade body will secrete pyrogen into our blood. At the same time, the macrophage which detect the unhealthy bacteria also secrete pyrogen into the blood. As pyrogen reach our hypothalamus, which is high vascularized and the blood-brain barrier is almost non-existent, so the pyrogen can move into the brain and act on the antitolicin. Result, endothelial cells start to secrete prostaglandin E2 to thermoregulatory neuron, which elevated the thermostat in our body. So now, your body start to undergo both thermogenesis and non-shivering thermogenesis. In order to reach the new altered set point, your body start to shiver and your blood constrict. This is why you feel cold when you touch your skin during fever. For your more information, some aspirin non-steroidal anti-inflammatory drug which block the produce of prostaglandin can release the fever condition. All from us, thank you for watching these videos. Don't forget to hit the subscribe button below. See you on the next videos. Bye!